So questions from lesson 6. Number 9. I'll do number 9 down here somewhere. In fact, really what I want is a copy of number 9. So this one here, Atla?
Yeah.
Perfect. Let's copy it. 10 kilogram mass, blah, 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 blah. Okay. Looks like they want me to find mu. Okay. I guess I'm hopefully going to be able to find an expression like a force equation. And in there, I hope there's going to be a force of friction. And hopefully I'll be able to get the mu by itself. There's kind of my attack. I have to dulp. I have to draw a little picture here because I can't quite visualize this. So I'm going to do that first before I do anything else. Did you draw a picture?
No, but I used mine from the one before.
Okay. In the one before, is the ramp the pointy part to the right or is the pointy part to the left? In your picture, just so my picture matches your picture.
I focus on the right.
So like this is okay? And it's sliding up. Okay. It tells me a bunch of information. It says VI was 4. It does say it came to a stop. D is 4.06. You know what? I can find the acceleration from that, which might be really helpful because then in my force equation, when I go winner minus blah, 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 blah equals MA, I'll know the A. Good. So let's do that. First thing I'm going to do then is A equals VF squared minus VI squared all over 2D. It's going to be 0 squared minus 4 squared all over 2 times 4.06. That's kind of handy. I can do that. 0 squared minus 4 squared divided by 2 times 4.06. A is 1.97. I'm going to ditch the negative. I mean, I'll put it there, but it's not going to show up in my winner minus loser. It's telling me it's slowing down. You okay with that part? Okay, I'm going to erase this because I want to have my force stuff down here. So I got that. Cool. I think I'd probably do a free body diagram. So there's good old mg, normal force. Which way is friction acting? Down the ramp, because it's sliding up the ramp right now. Okay. I would break this up into its components. So I have mg perpendicular and mg parallel. And 10 degrees is there, so 10 degrees is also there. Lovely right angle. I guess my equation is going to be winner plus winner equals MA, which is going to be mg, 2 lines is sine, plus mu times the normal force equals MA. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. mg perpendicular equals MA. Oh, perpendicular is of course it is, right? Normally I would show this all in separate steps, but I'm trying desperately to keep my diagram and my work all on one page so you can see it all. So I end up with mg cos theta equals MA. Conveniently. Okay. What are they asking me to find? What's mu? I don't know. What's mu with you? What's mu? Okay. So I think the first thing that I would do is I would minus this over to this side. And I'll get mu g cos theta equals A minus g sine theta. And then I guess I can, I think that's going to be it. But don't put the negative there. Is that okay so far? You did all that?
Yeah.
Let's see, 1.97 minus 9.8 sine of 10, all divided by 9.8 cos of 10. And by the way, I would consider this probably a B plus A minus level question. This is a tough question, although I could also argue, Sam, you can see I've done nothing new. Close off the top, divided by bracket 9.8 cos 10. Please tell me it says the answer is 0.02. What's the answer say for number 9? 78? 0.027. Woohoo! Yeah. Okay.
I think I did negative 1.9.
Which for kinematics, yes. But again, hopefully you're seeing, by the way, in that question, it's way easier to let down be negative. The math is so much nicer. Any others from lesson 6? Grant? No, that was just you adjusting here, number 93. Okay. Enjoy it while you got it, because you know you're. Yeah. 5? Okay. How long does it take 20 kilogram? That one there? I like that question. I like that question. I like that question. All right. Well, they're asking me to find time. I think I can assume VI is 0. D is 13. You know what? I think I can use this recognizing that that's 0. I think I can find the time by going 2 times D divided by A square root. Except I will also then have to find A. So even though this question is saying find time, I'm going to spend most of my time finding A. You okay with that so far? Let's draw a picture. Did you draw a picture? Is your triangle this way or is your triangle that way? Do you have the pointy part pointing to the left or is the pointy part pointing to the right? To the right? Like this? Yep, okay, so that way my picture will look like yours. By the way, there's no rule, but I just want my picture to look like yours. So you did this. There's our mass. And the angle is 8.5 degrees. And so you went like this, yes? And like that. Friction? Is this question mentioning friction? Oh, frictionless, so no friction. You did that okay? And then you went mg perpendicular, mg parallel. Yeah? And then you said, who's winning? I guess mg parallel is the only force down the ramp. Up the ramp there is no force, no loser, equals. Is that okay? Yeah? And then you said mg parallel. Why, that's actually mg. Yeah? And then you went, woohoo! There's A. So it's going to be the square root of 2 times 13, all divided by 9.8 times the sine of 8.5. Square root of that. Is that okay? Let's see if that works. 2 times 13 divided by 9.8 sine 8.5. Dueck, you got 2 numbers on the bottom. Put it in brackets. Oh, and the 13 didn't work. Let's try that. 2 times 13 divided by bracket 9.8 sine 8.5. Close off the sine, close off the bottom. square root woohoo 4.24. Okay. I would do more, but I want to get through today's lesson. If you have more, you can ask me in class. We paused on lesson 7. So can you find lesson 7? We paused on example 4. Example 4. So I wrote pause here. Let's delete that. Okay. Says this, if mass 1 has a mass of 8 kilograms and is accelerating upwards, which means I guess now I know who my winner and losers are. And if mu equals 0.12, okay, and the angle of elevation, blah, 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 find A, the tension, and B, mass 2. Oh, okay. Any suggestions on how I might want to start out? Yeah, it's labeled. Let's put our forces on here. Anybody not have lesson 7? I should have asked. I think everyone was here last day, right? Okay, well, left side isn't too bad. M1G, tension. Whew. M2G, normal force, tension, friction, yes or no?
Yes.
Yes, which way? This is why I had to give you the direction that one of the masses was accelerating. Which way is M2 sliding? Down, so friction. And I'll call it friction force 2, even though there isn't a second friction force, just to remind myself that it goes with mass 2. And yeah, Kyle, I can see you smiling. You're saying, hey, Mr. Dueck, you would break up gravity into perpendicular and parallel components. I agree. Now, I asked this in a very specific order for a reason. Justice, what's the first thing I said to find? Any thoughts on what we might do to find tension? When we've been asked to find tension, what has our strategy almost always been? Can we look at both masses? What happens if we look at both masses to tension? Why is Mr. Dueck smiling and relaxed? Okay, I did that on purpose because tension cancels. So I can't look at both masses. Let's look at one mass. Do I know mass 2? Then which mass should I look at, Justice? Can you give me an equation for mass 1? Looking at mass 1, who's winning? Who's losing? Okay, so if I'm going to do part A here, it's going to be, let's change colors, Mr. Dueck. It's going to be tension minus M1G equals M1A. Justice, can you get the tension by itself? Is that right? No, it's not. You made a mistake. Fix it. Right? Do I know M1? Yeah. Do I know A? That's why I had to tell you A. Do I know M1? Do I know G? You know what? I can do this. It's going to be 8 times 2.1 plus 8 times 9.8. How big is tension? You get 95.2? Nice. Newtons. So you follow my reasoning, Halen? I said, well, for tension, I can't look at both masses because it always can't. Do a stupid smile. Why am I relaxed? I'll look at one mass, which, well, obviously the one that I know. Hey, Halen, what do they want me to find in part B? You know what? I think what we're going to do is we're going to write an equation for mass 2. Okay. Looking at mass 2, folks, who's winning? M2G is not winning. M2G parallel is winning. I didn't hear a parallel. Ashley didn't hear a parallel. Maybe in some parallel universe. Parallel. Oh, sorry. That was funny, man. No, okay. Any other winners on mass 2? Anything else pointing down the hit ramp? Okay. Losers. What are the losers on mass 2? So minus tension. Okay. Well, M2G sine of the angle minus tension minus mu times the normal force I don't know the normal force. Oh, but look. I know another force the same size as the normal force. M2G perpendicular, right? Right, Rach? Yep. Okay. How much room have I got? Oh, lots of room. And perpendicular is which trig function? Of course it is. Do the M2s cancel?
No.
Why not? Why is it a good thing that they don't cancel? What am I trying to find? That'd be a little problem if they canceled. Okay. We need to get the M2s by themselves. So I think what I'm going to do, I'm going to plus this to this side, minus that to that side. I'm going to get the M2s by themselves. So I'm going to end up with this. M2G sine minus mu M2G cos minus M2A equals tension. Because because the tension has a minus sign in front of it, I'll plus it to this side, right? Just saying. Jake, you okay with that? What's yucky about this? How many M2s do I have on the left-hand side, grand total? 3. How many would I prefer to have? 1. How many do I have?
3.
How many would I prefer to have?
1.
Is there an M2 in everything on the left-hand side?
Yes.
It would be wonderful if there was a grade 9 mathematical operation that I could pull out of my back pocket and change this from 3 M2s to 1 M2. There is a grade 9 mathematical. I heard someone murmuring it. GCF. Is there an M2 in everything? Then Ty, from Math 9, that's a greatest common factor. Remember that from Math 9? Back when you talked like this? Remember that? So let's factor out the M2. Okay? We'll get this. Bracket. G sine theta minus mu G cos theta minus A. Now that's ugly. There's, Logan, no denying that's pretty ugly. But I'm arguing, how many M2s do I now have on the left-hand side, Logan? 1. Okay, folks, how would I get that M by itself? Divide by the ugly bracket. It's ugly. But before I do that, let's double check. Do I know G, 9.8? They gave me the angle. Did they give me mu? Yeah? They gave me the G. They gave me the, oh, and this is why I had to give you the acceleration at the very beginning. And do I know tension? Then I can solve for M. By the way, this is an A plus level question. This is tough. So I'm going to get this. Mass 2 is going to be tension all divided by G sine minus mu G cos minus A. But now, plug and chug. Tension was 95.2. All over G, 9.8. Sine, what was the angle? 8 point? No, that was last question. What was the angle? 28 degrees. Minus, what's mu? I don't know. What's mu with you? 0.12 times 9.8 cos 28 minus 2.1. Minus 0.12 times 9.8 cos 28, dunk. Minus 2.1, close off the top, double check for typos, 95.2 check, divided by, I need an open bracket, 9.8 sine 28 minus 0.12, 9.8 cos 28. Do you get 65.1? I won't give you one like this on the written. I would consider one like this as a fair game, as a nasty multiple choice, as the nasty multiple choice. Although part of me says, I'm not saying I like that question, like that question, like that question. Part of me says, I like that because the key to solving it is Math 9. And I have a soft spot for when I can pull out Math 8 and Math 9 in Physics 12. That's just the nerd within me. Is, oh, that's kind of cool. GCF. Who knew? So, in terms of homework, all right, you can try number 3. Now, to do number 3, they have to give you the acceleration. Hey, they gave you the acceleration. What's the acceleration here? 0, which actually makes the question, I think, a little easier. Okay, 4, 5 is overkill. Yeah, 6, finding theta is overkill. And I already assigned 7 and 8, right? 9 I skipped, 10 I skipped. So, I just gave you take-home quiz number 2. Okay? And you're going to notice in take-home quiz number 2 that most stuff is at angles. So, number 1, suppose this mass begins from rest. If mass 1 equals 2.2 kilograms and mu equals 0.44 and the angle of inclination is that, find the time that it would take the mass to slide a distance of 4.8 meters down the slope. Hey, this looks very, very similar to one I did earlier in class. Number 2, here's an Atwood machine. Find the tension. And then B, find M2, mass 2. Oh, this looks fairly similar to stuff we've just done. Number 3, here's your using principles of physics right to explain questions. So a student of mass big M places a bathroom scale on a skateboard. Of course, as soon as I'm talking about a scale, what force am I really talking about? Right? He then rolls forward on level ground while standing on the scale, which is still on top of the skateboard. What will the scale read? More than M, less than M, or M? The student now rolls a skateboard down a ramp, which is inclined at an angle theta, while standing on the scale. What will the scale read? More than M, less than M, or M? And using principles of physics, explain your answer to B. I think you can probably, with a good free body diagram and a couple of equations, explain your answer to B. Just saying. Number 4. Atwood machine combined with a ramp. Okay? Find the acceleration. And, oh, no friction. Well, that was nice of me. I should have given you friction. Oh, well. No friction. Oh, and then B, find tension. Oh, part C. What would the minimum coefficient of friction need to be between M2 and the rope? Sorry, between M2 and the ramp. And the ramp. In order to hold the entire system stationary. And then, number 5, skiing. A skier takes 8 seconds to reach a speed of 20 meters per second from rest while descending a 16-degree ski slope. What is the coefficient of friction? What's mu? I don't know. What's mu with you? Okay. These are all fairly challenging. I did not put any C or C+ level questions on here. These are all B level and higher questions.